Wattage rating. The wattage rating of a power supply is the most common specification people look at when building or repairing a computer. It represents the total amount of electrical power the unit can safely deliver to all the internal components combined, measured in watts. Think of wattage as the size of the fuel tank and the strength of the engine. It determines exactly how much hardware the system can support without crashing or catching fire. Understanding the total power capacity. Every component inside a computer consumes electricity. A simple office computer might only need 300 watts, while a high-end gaming machine with a massive graphics card might require 850 watts or more. The wattage rating on the side of the power supply tells you the maximum limit that the unit can handle under a full load. For a technician, the goal is never to use 100% of the rated wattage. If you have a system that draws 500 watts, you should not install a 500-watt power supply. Running a power supply at its absolute limit causes it to generate massive amounts of heat and significantly shortens its lifespan. A professional best practice is to choose a unit that provides about 20 to 30% more power than the system actually needs. This extra space is known as headroom. How to calculate system wattage. When you are tasked with installing a new power supply, you must perform a basic power audit of the components. The two biggest power hogs are the central processing unit and the graphics card. A high-end processor might pull 150 watts, and a powerful video card can pull over 300 watts on its own. Beyond the main chips, you must account for the smaller draws. Each mechanical hard drive takes about 10 to 15 watts. A stick of memory takes about 5 watts, and each cooling fan takes about 3 watts. You add all of these numbers together to find your total system draw. If your math says the computer needs 400 watts, you should recommend a 600 or 650-watt power supply to ensure stability and allow for future upgrades, like adding more storage or a better video card. The continuous versus peak power trap. A common mistake for beginners is falling for the peak power trap found on low-quality power supplies. Some manufacturers will print a large number like 700 watts on the box, but that number only represents the peak power, which is the absolute maximum the unit can handle for a few seconds before it shuts down. A high-quality power supply will always list its continuous power rating. This is the amount of power the unit can safely provide 24 hours a day, 7 days a week. If a power supply label is vague about the difference between peak and continuous power, it is usually a sign of a low-quality unit that should be avoided in professional environments. The importance of the 12-volt rail in wattage. In modern computers, nearly all the heavy lifting is done by the 12-volt rail. A technician must look closely at the power label to see how much of the total wattage is actually available on that 12-volt line. For example, a poorly designed 500-watt power supply might only offer 300 watts on the 12-volt rail and give the rest to the 5-volt and 3.3-volt rails. Since the processor and graphics card only use the 12-volt rail, that 500-watt unit would fail to run a powerful gaming computer, even though the total wattage seems high enough. Always look for a power supply that can deliver almost all of its rated wattage on the 12-volt rail alone. Troubleshooting wattage issues. If a power supply wattage is too low for the system, the computer might work fine while you are just browsing the web, however. The moment the user starts a heavy task like rendering a video or playing a game, the system will suddenly turn off or restart without warning. This happens because the components are trying to pull more fuel than the power supply can provide, causing an internal safety circuit known as overcurrent protection to trip and shut everything down to prevent a fire.